Hello. Um, this is the continuation of our class, and in this class, I'd like to talk on the next topic, and the next topic is operating systems and computer architecture. So, what is operating system? Basically, operating system is a software, okay, is a software running for systems, for computer systems, and they are useful for the following things: multitasking, they are useful for error handling, they are useful for security, they are also useful for input and output control. So essentially, operating system allows you to be able to open many applications at the same time. That's the multitasking aspect. It allows you to be able to refer to and anticipate, detect, and resolve programming and application errors, even communication errors, communication application errors. Like for instance, when your error is not running, it's the one that prompts you and tells you that okay, out of memory error, or your application directory has been moved, you know, or your application cannot run on the current operating system. It gives you these errors and it helps you to adequately handle the errors. So instead of having a total shutdown or system hanging, they have now been improved to be able to handle error by just displaying simple messages. And also it helps with security, password, and other information that will help you to be able to authenticate your ownership or control, or transfer ownership or control to a particular user. That means that even if you're not using your system, you give somebody else your system, then you're able to give them the login credentials, which are like permissions to use it. Then input and output control, controlling devices like printer and all that. I'm sure you don't just print directly to your printer, you connect your printer to a system. And so it's this operating system that helps you to identify and helps you to drive your printers, drive your scanners, and all these other application machines or devices, output devices, and even input devices. Is the one that helps you to coordinate everything. So when we talk about operating system, what are the examples of operating systems that we have? Now, of course, we have different platforms, but basically the common ones we have Windows, and we have different versions of it. So you have Windows XP, you have Windows 7, you have Windows 10, you have Windows Vista, you have Windows 8, you have Windows 8.1, and so on and so forth. Then you also have Mac, and you also have the different variations of that also. Then you have Linux, that's another example, and you have the different variations of it. So you have the Ubuntu, you have the Red Hat, you have the CentOS, and so on and so forth. Then also you have now, which is prevalent, the Android, which is more of a mobile, but it's not only mobile, but majorly essentially a mobile driven operating system. Then you also have other rare ones like Unix, but available, and you have the DOS, which is also available. So when we talk about operating system, it's very important for you to be able to understand that when we talk about operating system, we're talking about like a kind of platform on which other platforms are based. And by the way, when you think what's the full meaning of DOS, it is disk operating system. Okay, please don't forget that disk operating system. Okay, so we have different types of operating system like I've listed to you now. So one of the other things that we say that we can see about operating system. Now, when computer is first powered up, the initial programs are loaded into the memory, of course, and that kind of memory is what we refer to as a ROM. That could be our on our BIOS. Okay, it could be our BIOS. Then BIOS, BIOS. Okay, look for the full meaning of that, basic input output. So this makes sure that the hardware processor internal memories are functioning correctly. Okay, so if there aren't errors, the OS will be loaded into the memory. So that's where you now see that you have your logo. That's kind of, if you are using Windows logo, that shows at the beginning, depending on which version you are using. Okay, so if there are any error, OS is loaded. And then also when you see you shut down the OS resources that are temporarily stored on a temporary memory, they are deleted, and that temporary memory is the what? Is the RAM. Okay, that temporary memory is the RAM. So it's very important for us to understand that this, of course, process repeats itself over and over again. However, the parameters, that means that, for instance, if you use Microsoft Word, which is stored temporarily on the RAM, then when you shut down, next time you open you boot your system, is PowerPoint you used. I mean, it's PowerPoint that will temporarily be stored on RAM, but the procedure is basically the same thing. I hope you understand that. The procedure is basically the same thing. That means that temporary memories, temporary storage or temporary resources are stored on the RAM, while permanent resources are stored on the more permanent or more persistent resources. I think the word persistent now. Persistent. Yeah, more persistent resources are stored on the hard disk. Now let's look at interrupts and buffers. Interrupts and buffers. So when we talk about interrupts and buffers, what do we mean? Interrupts are signals that are sent. They are signals. Okay? They are signals that are sent from a device or from a software to a processor. This means that the processor will stop temporarily during the interrupt. So that means that whatever the processor is doing, it will stop temporarily to allow for the signal to come in. Now, this interrupt happens because the disk drive is ready to receive more information. Now, that means that now the CPU, let me use that general word, is ready now to concentrate on the signal that is being sent. So, when signal is being sent from when signals are being sent from devices or software, there is what we call interrupt. You understand? Interrupt is not really the signal. Please, let me just make that clarification, contrary to what I said earlier on. The interrupts are not the signals, but it is what happens when signals are sent. It's just like, for instance, I am speaking to person A. I am speaking to person A. And person B now comes. Now, person B is said to do what? He is said to have interrupted the conversation I was having with person A. Is that okay? So that's how it is. So interrupts are signal that when signals are sent from devices, okay, to the processor, okay, the processor will have to stop temporarily, okay, and this is due to the fact that this drive is ready to receive more data, or error has occurred, okay, or a particular control button has already been pressed. So you can say that interrupts are triggered by, for instance, this being ready to receive more data, error has occurred. Okay, so let me just list it now. So interrupt occurs as a result of, number one, disk drive data entry or need for processing, error occurrence, okay, command action triggered by command button, okay, or even software error. Okay, let's just generalize everything under error occurrence. I hope you understand. So that's that about that. It's very important you understand. I'm building up something here. I'm building something up here. So please don't be in a hurry just yet. I'm building something up here. What I'm building is, I want you to understand how the architecture, how the CPU works, what it feeds it, what it is broken down into. You know, when you say CPU, then the secondary school knowledge will tell you it is broken down into ALU, arithmetic and logic unit, CU, the register. In the case you have a single register CPU, you call that register accumulator, you know. So I'm building something up so that gradually we probably can understand. Maybe later in the future, I will augment this with other materials. I hope you understand. So in the meantime, please, I want you to be able to at least grasp what I'm saying. Be patient enough to grasp gradually. Is that okay? Now let's move to a particular model we call the von Neumann model. Isn't it? Von Neumann model. You can look at it. You you can look at it online, but this is the spelling. Von Neumann model. Okay, so what is the von Neumann model? When we look at it, it was invented by somebody called von Neumann, and that's what is most time the occurrence with computing architectures or computer-based architectures. Usually they are named after their propounders. Okay, so it was by Neumann, this man von Neumann, in 1954. If you listen to a little bit about computer history, then you'll be familiar with von Neumann. Okay, sometimes some people refer to him as the inventor of computer and so on and so forth. Anyway, because of the role he had to play in processor. So in case you're wondering, what are we talking about now? We started with operating system, but now we have now moved into what? CPU. Not just CPU, we have moved into the CPU architecture. Do you understand? So von Neumann, he was the one that came about this model. And what's this model all about? Von Neumann's computer, his own ideal computer, contains 5 main building blocks. 5 main building blocks. Let me list those building blocks. Now, he came up with this, that you have CPU, that's the central processing unit. That you have the what? MU, that's the memory unit. That you have what? ALU, that's the arithmetic and logic unit. Now, that you have input and output, which we often denote as I/O. Okay? So now, when you look at it, we basically have 1, 2, 3, 4, 5. Do you understand now? So these components are together using the system bus. So now, this is 1. Okay, so all these are using what we call the system bus. Now, what is the system bus? Now, let me isolate this now. I just use this to explain to you. Now, if you recall, USB rather, Universal Serial Bus. Now, if you come to think of it, you know how I think of bus? I think of bus as something that is essential for transportation. And if that is only what you think of at this point, now you are safe to think of it, because you are not likely to run into trouble. So basically, you have instructions, signals, need for interruption, data flying all around, the system moving, even though it might not be in visible form, it might just be in the zeros and ones form. But you have these things being transmitted, and not just transmitted at an alarming, at an intriguing speed. Do you understand? So von Neumann identified these things as essential. Okay, so in his own model, you can say these are the components. So if you ask the question, what are the components of von Neumann's model, the model of his own computing, these are the models. Okay, now let me look a little bit at it. MU is referring to the storage of information, that is data and program. Okay, then PU is talking about PU basically is just talking about MU, yeah, that's what I have. MU is talking about storage of information. PU, which is central processing unit, is talking about processing of information. Okay, so processing of information. Then you have the input, which is your keyboard, your mouse. Okay, I think that's straightforward. Then you have your output, which is your monitor, your printer. Okay, then, or your speaker. Then you have the control unit. Now the control unit, which is part of the PU and makes the CPU, make sure that all the other parts of the computer perform their correct task at the correct time. Now you can just say this, that it is used for coordination